Yes.
Okay, perfect.
Yeah.
Okay, so a few weeks ago I did an intro to like metabolism PowerPoint. So I'm gonna start with glucose metabolism, which there's like glycolysis, gluconeogenesis, and like glycogen synthesis. So I'm just gonna start with glycolysis. It's gonna be pretty short, I think, but yeah, this is what I read. Okay, so glycolysis is the conversion of glucose into pyruvate, which is a 3-carbon intermediate. And I'll go over more about what pyruvate is in a second. But glycolysis is the first 10 steps of glucose metabolism. And this is very important because glucose is the major source of metabolic energy in cells, and in some cells it's the only source of metabolic energy. And then as well as this, it also provides precursors that are necessary for the synthesis of other biomolecules such as lipids, proteins, and so forth. So pyruvate is the one over here. So we start off with glucose, which is a 6-carbon sugar, and we end up with a 3-carbon pyruvate here. This can be converted. I'm going to move this. This can be converted into various other intermediates. So if you look at the diagram over here, glucose goes to pyruvate, but pyruvate can also be converted into acetyl-CoA, which can be further used for the citric acid cycle. It can also be used it can also be reduced to lactate, which will regenerate NAD plus for glycolysis again. And it can also be used to synthesize, to regenerate energy for glycolysis, like I just said, yeah. So glycolysis is an energy investment for the first 5 steps, but then you get an energy payoff, which is obviously the point of it, because you want to have more energy to be able to do other things. So the first 5 steps, you have an investment of 2 ATP, and you end up at the end with a gain of 2 ATP, because the first 5 steps you use 2 ATP, and then you end up gaining 4 ATP at the end, so the net gain is 2 ATP. So I'll just explain what ATP is. So ATP is this structure over here. It's an adenosine triphosphate. So there are 3 phosphates here, and these bonds have high chemical potential energy. So this is why we kind of refer to it as energy investment, energy payoff. And you'll see that we will see ADP and ATP. So ADP is the same thing minus 1 phosphate. So if you have an ATP, you're gonna like remove 1 phosphate, and as you can see here, this is delta G, so the change in energy. So if you have ADP, you want to have ADP and phosphate to get ATP. It's gonna make more sense in 1 second, but yeah. Okay, so these are the first 5 steps. I'm not gonna go into like the minute details of how everything changes, because I'm not quite sure, honestly, and also it's really long. But basically, you can see over here that you have ATP because the first 5 steps we're going to use 2 ATP so that we can gain more further on. And we will get a phosphate from that and end up with ADP. And then over here as well, at the 3rd step, that happens as well. And we end up, after the first 5 steps, with 2 3-carbon molecules, which is a bit closer to what we saw pyruvate looking like. And then for the last 5 steps, you can see here that there's the NAD plus and the NADH, which is another form of energy. Like NADH can be used to have ATP, so that's also like considered energy. but yeah, so you can see down here that we get ATP at the 7th step and the 10th step, and we also get NADH. So, and the reason why it's 2 here is because all of the molecules here, there are 2 of them because it's a 6-carbon molecule, right? So we're getting 2 3-carbon molecules. So we end up having 4 ATP as well as NADH, which is more than we started off with. And this gives us a net gain of 2 ATP, like I already said. So we have glucose and 2 NAD plus, plus 2 ADP and 2 phosphates. And this gives us 2 pyruvate molecules and 2 NADH plus 2 ATP. And this pyruvate, like I mentioned, can be used to continue in the citric acid cycle, which will help with the synthesis of other biomolecules as well as giving us more ATP, more energy to do other things. And it can also be converted into other things, as I mentioned, the synthesis of other biomolecules, such as lipids. That's it. It's just a short little bit.
Thank you, Emily. I hope this is helping with your MCAT preparation.
Yes, it definitely gives me an incentive because I don't always feel like pulling out my biochem textbooks, but it's actually really useful because I'm getting more of like an overview of how everything works, like in comparison with just like a bunch of steps that were thrown at us in class. So.
I don't see if anyone has any questions. I personally can't think of any questions. Do you mind if I just ask how your job's going?
Yeah, it's going well. I just finished I had my training and then we had 6 days off, but I just finished my actual first week of